Hello, I'm Kathy Nash with the ACES staff. I'd like to welcome everyone to today's webinar, which is entitled KNIME Analytics Platform, sponsored by DCMI and ACES. Our distinguished presenters today are Magnus Pfeffer and Kai Eckert. Our moderator is Jacob Jett, who is the web coordinator for DCMI. I just want to ask the audience, as you have questions today, please type them into the question panel box. And at the end of the presentation, Jacob is going to moderate the questions and the panel will answer those for you. I'm now going to turn this session over to Jacob, who will introduce our speakers. Jacob?
Thank you, Kathy. I'd like to introduce Professors Kai Eckert and Magnus Pfeffer. They both work at Stuttgart Media University at the Web-Based Information Systems and Services. They both work with semantic web initiatives, linked data, data cleaning, data initiatives, kind of data organization, information organization. And they're here today to present their new tool, KNIME. And without further ado, I'm gonna step out of the way and let them take it.
Thank you, Jacob. I will start with the first part of the presentation. I'm Magnus Pfeffer, and I will cover of this presentation 3 parts. First part is a very short introduction to the KNIME Analytics platform. We will go through some basic concepts and an example workflow. The second part is a more in-depth look at how to deal with simple type of data, filtering data, changing some values, grouping data. And then we will have a short excursion into non-tabular data, XML or JSON data. And as a final part of my part of the presentation, we will have a short look at visualizing data with KNIME. Kai will take over and give you an outlook on the possibilities of the software by showing you how to do machine learning on the same framework. So, given that we only have 1 hour, we will go quite quickly through these parts. If you feel that it's getting quite hectic, feel free to fall back to the recorded session. And I would like to announce that we plan on putting some blog posts on the DCMI webpage containing all the information from this introduction in more depth with all the data files and examples included in the blog posts. So you can refer to them if you want to follow the examples and other parts at home. So, coming to KNIME. So why do we choose to show you the KNIME Analytics platform? KNIME is open source and is free, and it's a GUI-driven data management application, which is very flexible and supports multiple types of different workflows. It brings a ton of extensions for all kinds of data-related work from third parties as well. And it has great documentation, great online learning resources, and a very active community. In our opinion, KNIME is a very interesting piece of software because on one hand, you have software like MarkEdit or other tools that are very specific for very, very small set of problems. And on the other hand, you have completely freely development with any programming language you could imagine, like Python or Java or anything else. And KNIME, as a GUI-driven management application, is focused on data, but flexible enough so you can solve very complex problems with it. And we think it's a very easy way to get into solving more complex problems with data. And we would like to show you what's possible with KNIME. The basic concept KNIME is using is the so-called workflow. KNIME interprets the problem of working with data as a pipeline or a graph. You see here in the picture colorful dots connected by lines, and these are called nodes. Every node, every colorful dot in such a graph is doing something with the data. It's either reading it or it's working with it, it's changing it, it's finding something, it's writing it, it's analyzing it. And all these nodes are color-coded according to their main function. In this example here are 2 different ways to read data from a file and from a database. And you see yellow nodes working with some kind of something, doing something with the data they do. Each and every node can be set up interactively and configured, and they are connected by so-called links. These are the arrows between the colorful node dots, or squares to be more precise, and these are direction. They have a start and an end, and the data processing follows these links. As you can see in the small example here on the slide, the data processing starts at the left at the file reader and the SQLite database connection, and then data is being read, columns are renamed, things are concatenated, and so on and so forth. It is important to understand this concept because everything else follows from it. And KNIME makes very good use of this great visualization way because you can create quite complex workflows with lots of nodes and still know exactly what's happening with your data. You may have noted that some of these or all of these nodes have a little traffic light under them. This is the processing status. And unlike code, where you sometimes run a program and you may not be sure what's happening and where your program has stopped or does it still run, here you immediately see in the interactive view that your node is being either red, which means it's inactive and hasn't even been configured yet, yellow, which means you successfully and fully configured it, but it has never been run or executed, or green, which means, yes, it has been properly configured and executed, and it ran without errors. One word to the KNIME installation. You can download versions of KNIME for Windows, Mac OS X, and Linux at the knime.com site. There is a big download button on the top right. And just one more information, of course, like every commercial entity, KNIME would like to have your personal information so they can send you emails and newsletters and stuff. But you don't need to do that. You can simply click on the Download KNIME button here and download the version without leaving any personal data, if that is something you would prefer. This is a screenshot of the KNIME Workspace Layout. And while this might be overwhelming when you see it at the first time, it's a clearly organized workspace that combines a lot of functionality and can be adjusted to your own needs. So we have on the top left the workflow management area where you can see all your workflows that you can organize in different drawers and your choice of organization form. You have a node selection, which is a huge repository of all the possible data processing nodes that are available for the KNIME analytics platform. And on the right, you have a documentation window. And these windows always interact. The second you click on a node in the repository, the corresponding documentation will show in the documentation window. The second a node is being run and creates an error message, it will be shown in the logs on the bottom right. And you work with this workspace in the center, the active workflow, by dragging and dropping nodes from the repository to the workspace and then connecting them using the links. I will show that in greater detail soon. But it's important to remember these windows can all be resized, made bigger, maybe completely closed if you don't need them to suit your needs. So how does one use KNIME and how does the functionality interact? In this first part, we will see in a very, very simplified workflow how to deal with the concepts and connect them to create a sample workflow. First thing is we need to read data. KNIME as a software internally stores data as tables. So very similar to Excel, or if you are more used to comma-separated value data, you have columns of data, rows of data, columns describing what type of data it is, rows being the data of a single entry or document or whatever your data is structured accordingly. And the good thing is CSV and Excel data can of course be read one-to-one into KNIME. So if your data is already available as a CSV or Excel file, it is basically drag and drop into KNIME to read the data. All you have to tell KNIME in the configuration of a file reader node would be to inform it about the delimiter character that is used for your data and whether your data contains a header line or not. Speaking of this tabular data, KNIME of course supports multiple data types. You have the usual suspects available, so all your numbers like integer numbers or decimal numbers, strings, but also other data. Possibilities include date, time, or even XML and JSON data. I will speak later about how to deal with XML and JSON data in KNIME. The good thing, the file reader node already tries to guess the correct type by doing a heuristic analysis of the data you are trying to read. In this example here, we have a short preview window, which tells us that KNIME considers the first row, which is called the first, column, which is called name, to be of string value. The year is interpreted as an integer number, and North America sales are considered to be decimals. And you can easily click in the configuration interface to change the data type if the heuristic made a mistake. I will now introduce a few very basic tasks that are often being done with data and show you the corresponding nodes in order to then show you with the software a workflow that contains all these steps. So one basic way to deal or to do anything with data is to filter it. Your data might contain a lot of columns, a lot of information, and a usual use case would be to reduce the amount of information that is available. You might want to share a data file with your business partner, but you would like to drop the price information that you pay to your suppliers and keep that secret. So you would want to give the data to another person, but remove some columns. So there is, of course, a node for that. It's called column filter. And its interactive configuration shows you the list of data columns that are available. In this example, there are 4 columns, and you can simply drag and drop or push the little arrow buttons to move columns from the include to the exclude part and get rid of them. Another way to filter data is not to remove columns, but to remove rows from the data. Usually, you'd want only a part of the data to further analyze or send to another party. And the row filter node does exactly this. Again, it knows about the data that's incoming because it already knows what node it is connected to. And it can already tell me, you have the following columns to test. So what do you want to do? So I can tell the node to either remove or include data according to row number or according to its value. Here I chose to test the column year and to use a range check and to include only those rows that have at the lower bound 2010 and the upper bound 2015. Another very common thing to do with data is manipulating strings. And as you would imagine, KNIME brings a very powerful node for string manipulation. This node can either work in place by replacing existing data, or it can append new columns with the new information. It brings very powerful string functions that are very similar to the functions you'd expect in a full programming language like Python or Java, but also simple search and replace and other functions with it. Here, configuration becomes more complex. instead of simply telling the node, remove this column, you now need to tell the node exactly what kind of string functions you want to use on what data. Again, this example shows the configuration window, and you can see here that the software tries its very best to make this very complex node approachable for people who are not used to programming. First of all, you have a category that combines similar functionality under a reasonable heading. Here, for example, all the functions to change the case of a string. And you can now see the 4 functions that are available are capitalize, lowercase, and uppercase, all doing what their name implies. But there's a full description describing the working of the function and tons of examples to see how would this react. What would happen if a lowercase processed by KNIME, it would become processed by KNIME all in lowercase. What happens if I lowercase an empty string? It stays empty. What happens if I lowercase a null string? It stays null. And in the window below, you have to create the expression here, for example, combining lowercase title and counting the numbers of the in the title. Again, these configuration options are both well described, and when you close the configuration, it will be checked. So if you make a mistake in the expression, you will not be able to leave the configuration of a node. The next node to introduce, and I think it's almost the last, would be the same question: how do I deal with numbers? There is a corresponding node to the string manipulation node that's called math formula. Again, because it's a manipulative node, it can replace information where it resides and change the data, or append new columns. And it basically has all the mathematical functions you could think about, from basic arithmetic to trigonometry to statistics. We will use these nodes to create a sample workflow soon. But the final one to show you is the node to manipulate data not based on mathematical functions or string changes, but on rules. This is the if then else, or if this is like this, do that. So here you can create very powerful rules to create new data from your existing data or to replace existing data. The most common, or one of the more common ways to deal with data, is to aggregate data and group it by a certain attribute. The group by node of KNIME fulfills this function and is very powerful. Its configuration is done in 3 steps. And first, it is telling the group by node what data column or what data columns should be used to group the information by. The next step is to tell the node what groups, what columns these groups should be worked on. So what part of the information do we want to analyze or do something else with it? And finally, we tell the node what to do. Here is an example. We have 4 available columns. We chose to work with year, and we want to count the members per group per year. So if our data is organized by having an attribute for the value year for every data set, we can count all the different pieces of information per year by simply using the group by node. And it can do much more than simply counting. It can calculate mean or median value, max and minimum values, sums, and tons of other statistical information. After this very short and very rushed introduction to the concepts and to some nodes, I would like to go with you through creating such a workflow. Here we took an interesting data set from kaggle.com. Link is in the slides. It contains sales information on computer games. The columns are quite easy to interpret. They contain the information rank, which is the sales rank of the game, the name of the game, the platform of the game, meaning is it a game for the PlayStation or Xbox or something else, the year the information is related to, the game genre, the publisher, and sales information separated into North America, EU, Japan, and other, and global sales information, which is the sum of all the 4 separated information pieces. It contains quite a lot of information and is a very interesting data set, and I encourage you to have a look at it later. But for our basic workflow, we want to achieve the following things. We want to be able to read the data from a CSV file into KNIME. We want to learn how the data looks in KNIME and try to use some of the nodes I just described. There's a lot of information, so we could remove some columns and make it easier to interpret and inspect. We want to limit the data to data from the year 2012. And because this is still quite a lot of information, we want to group the information to get a more abstract view on this data. Here we choose the genre to group the data by and count how many games are there per genre in the year 2012. And calculate the mean value of the sales volume to see what game was, or what type of game was more expensive than others. So let me switch to KNIME so you can see the software live. Given that this is a live presentation, I'm hoping this does not crash on me, but wish me luck. This is what KNIME looks like when you start it the first time. It contains the windows I discussed before, the Explorer showing you your workspace. In my case, I have a ton of workflows already made in some data files, the repository, the description, the log in the bottom right, and a center window, which here says hello to me because I just started KNIME. And I now want to start a new workflow by clicking on the new workflow wizard. We just want a KNIME workflow and we give it a name. And we are greeted with a blank page. Like I said before, the basic interactive model of KNIME is drag and drop. The idea is that from the node repository, you choose the node you need and drag and drop it to the workspace. In our case, we need a file reader. And I can use this little search box to search for the node, see there's a file reader, and drag and drop it to the center window. Now our workflow contains of a single node and no link. Notice the red traffic light, the exclamation mark telling me this is not being set up properly. You need to configure your node before you work further. To configure a node, you interact with it by clicking with the right mouse button, and you get a context menu. Not only can I change its description and copy and paste, but the most important thing is I can configure my node. But before we start the configuration, I would like to show again the interactive description window. The second I select this node as the active node, the description changes and gives me a comprehensive overview what the node does, how its dialog options work, and where I can find more information if this is not sufficient for my needs. Let's configure the node. The first thing we need to do is to give the data file location. I cheated and put it into my copy paste buffer so I don't need to browse through my file system. And here it's my web path to the data. It's a CSV file. And the preview immediately is populated with the first few lines of the data. I can now inspect my data and see if the automatic configuration options are right. The column delimiter obviously is right. If it were wrong for whatever reason, I could change it here and immediately be greeted with an error. So comma was right. We can see that the name is correctly identified as a string, the year as an integer, and the sales as a decimal number. Column headers were found, and they are name, platform, and year. But also it decided that the first row contains numbers, so it might be the row ID. But this is our sales rank, and I want to preserve this information. Clicking OK switches the traffic light to yellow. We now have it fully configured, and we can now run the node. This is done by clicking on the little green play button up in the menu or in the context menu of the node. And now the node has been successfully executed. We can now check the contents of the KNIME data table by checking the context menu for file table. And we can see all the data. Let me now construct the workflow, given that we have very short time. This is going to be a little bit faster. So the first thing was to remove columns from the data. So we put the column filter here, configure, and remove the North America, EU, JP, and other sales. OK, and execute. Have a look at the data. And we now see only the global sales remain. We now want to filter the information. So we use the year, and we want the year 2012 to 2012. We can apply, execute the node again, and inspect the data. We have a look at the year column. It only contains information from the year 2012 now. It's still a lot of rows, so let's use the group by function. Group by. Group by. I want to group by genre. Like I said, the first step, choose what group columns are used. It's genre. Next step, we want to count the occurrences of games. So we pick any other column and choose the aggregation count. Apply and execute the information. And now we see a group table. And here we have the information we were looking for. In the year 2012, the action genre was 2,066 games, while the simulation genre only had 18 games. How about the sales? Again, we can group by genre. And now we want to work with global sales and calculate the mean of the sales per genre. Execute and inspect. And now we see the mean value for action games was 0.4 million, while the mean value for platform games was 1.5 million. Obviously, you make a lot of money with platform games in 2012. But let's have a look, how many were it? It was only 12 games, but they sold a lot. Interesting. And I hope this gives a first impression how you would work with the data workflow in KNIME. It's very interactive. You see exactly what's happening after you choose to add a new node to your workflow. And this helps you slowly build up your workflow until you reach the kind of information you need or the type of data change you want to see. I have a few more minutes, and I just would like to give you a first overview of what would you do with non-tabular data. XML and JSON are the examples we would like to talk about. They are structured data. They can form trees and very complex data structures which cannot be read one-to-one into KNIME. So KNIME deals with it by first treating XML or JSON as a data type. So any data table in KNIME can contain columns with XML or JSON cells. And again, there are nodes that work on JSON and XML cells, just like there are nodes that work on strings or numbers. The way it's being done is quite interesting. It's using XPath queries to take little parts of the data from the XML and put it into a column. Our time is too limited to explain how XPath works, but the fun fact is the configuration of the XPath node is interactive. You don't need to know about XPath, you just need to know about your data. Simply click on the data you want to pick from the XML. In this example, I clicked on the year information. Year equals 1999. And here, in green, it already selected the corresponding XPath that I can then use to take all the year information from my data file. And this is really handy because usually we work in our field with data that has a lot of records with recurring elements. So by simply clicking on each element once, I can create an easy transformation from XML to a flat CSV file. And correspondingly, the XML reader basically needs nothing more than the input location, and it will read all the XML data in a single cell. And if I want to separate the records, I can use an extra XPath filter to separate the records into individual cells. And the same happens with JSON. Instead of XPath, there's JSON path, which is a completely different syntax, which I personally always forget how it's working because I rarely use it. And then there are two confusing and quite interesting ways to express the same path in JSON path. And again, simply click on the information, click on the button Add Query, and I get the information I need from my JSON into a nice column labeled Jahr, which is here the German data for year, and I can work with JSON data. The JSON reader works exactly the same. It has an input location, you can name the output column, and you can tell them a path expression to separate records into individual cells. I'm close to the end of my part of the presentation, and the final thing I would like to introduce is, besides many other possibilities with KNIME, KNIME also brings a lot of visualization with it. From the regular charts with line and bar and pie charts to map visualizations, everything is there and easily interactively configurable. I would now like to continue with my work here by using the information here I gained in my workflow to visualize it. So I can search for graph, and apparently I mistyped, but I can also use views and click my way to the thing, and I would like a line plot. Why not? We feed the information to the node, and here we have to tell the node what we want to plot. So what is our x-axis? That would be the genre. And what would be the y-axis? That would be the count. So let's remove the genre because we already use that. And we can here execute and open views to see the information. So here we see a line plot of the information we saw in the example before. Remember, Action had 266 counts, so we can use this to visualize using this kind of graph. You can do more and we will add in our blog post informations and examples for all the visualizations in KNIME. And given that I've already exceeded my time, my allotted time by 5 minutes, I would like to hand over to Kai and ask him to give us the outlook on machine learning using KNIME. Just a second.
Yes, thank you, Magnus, for the introduction. And I will, as quick as you did it, give you a brief introduction how you can use machine learning in KNIME. We think that KNIME is especially a useful tool because it is very intuitive, as you have hopefully seen. And you can actually work your way through maybe even new workflows and try things out. And I think this is especially true also for machine learning. In many projects, I often use Python and Pandas and the like, and they are also very powerful. And you can always use these kind of famous 3 lines of Python to put things together. But especially when you are new or when you just want to try out something, it helps a lot that you can use KNIME interactively, find the nodes that you would like to use and just try things out in a way as we have seen it so far. So we will now try this with machine learning. You have everything that you need in KNIME to work with machine learning. You can integrate it in your data workflows. And there are similar tools like, for example, RapidMiner that are maybe even more dedicated to the to machine learning and data analytics. So if you know this, you will find similar things in KNIME as well. The example here I took from the KNIME tutorial. There's a lesson dedicated to machine learning and data export in this case. So if you want to try it out, I would like to encourage you to go on knime.com and just take this tutorial and do the exercises. And with the introduction here, I think you will be fine in finding everything that you need. When we talk about machine learning, we have to, of course, decide, especially also in this short time, what we would like to do. Usually you can, or you have several tasks that are associated with machine learning, unsupervised learning, supervised learning, and reinforcement learning. Unsupervised learning are things like clustering or data mining. Supervised learning is something like classification, which is very often used, and we will also use it here in our example, where you have a lot of data and want to classify the data, for example, into, I don't know, genres with good sales in contrast to genres with not so good sales, or something like this, to stay in this example. Regression is supervised learning when it's not about a strict classification, but rather the learning of a number of some variable that you actually want to get, like for example stock values. Then we have the field of reinforcement learning, which you will find a lot in robotics, game AI, and real-time systems. So just a big picture about what falls into machine learning. As I said, we will focus on the very typical task of classification. I would also say that's the most common task when you work with the data like we usually do. In a machine learning project, you have to do several things, and the most time usually goes into the stuff that you have seen, that Magnus just demonstrated. Actually getting the data, cleaning the data, deciding what data to use, and so on, takes a lot of time. And then, if you did it right, you actually can do the learning quite quickly and can check the results. And in the end, if it actually works, you can use it in your systems and do the actual deployment. So as we saw already how the data can be prepared, and we will of course not talk about the deployment today, we are interested in what KNIME brings for us to do the training on some data and also to find out if it actually worked. When you do this, the first thing you have to do is to partition your data. You have to decide what data is actually used to learn from, to train a machine learning system. And you need some additional data, the test data, to actually check if it worked. So this is always the first task, at least when you do supervised learning. Typically, you use something like 80% of your data for training and 20% for testing. And you often also will see that there's also validation data, additional data in real-world scenarios that you, of course, use after you tuned everything and you think everything is right. You do a real-world test with even more data. So if you want to do this, we have a node here, the partitioning node, that you can just use. You give it some data, you tell it how much of the data should be used for training and how much should be used for testing. And you have different strategies to actually do this splitting or partitioning of the data, something like random selection or whatever you want. In a real scenario, or maybe you know already about this, you would typically not just use some 80% for the training. You try to get the most out of your data, and you do what is called cross-validation. You basically take 80% of your data and test with the other 20%, and then you take another 80% of your data and test with, again, a different kind of 20%, and so on and so on. You can do this 5 times. It's the so-called 5-fold cross-validation. I tell you this because it allows me to at least show you here in this example quickly what you quite often find in KNIME. Because if you want to do this, you need a loop. You need 2 nodes that work together, because here you see you have to do this 5 times in a row. And KNIME does it for you, but you need 2 nodes. And there are several workflows or several tasks that you might have where you sometimes end up that you actually need such a loop. And these structures are available in KNIME. So for cross-validation, you take an X partitioner, a cross partitioner, then you can learn something. And then you have this predictor here, and there's this additional loop. And then we have this is just the predictor, but then we have the cross aggregator who actually aggregates the results and takes care of this 5-fold or whatever kind of folds you want to need for cross-validation. So this is how it looks like. I think this is especially interesting if you actually know already about machine learning and are just interested in how does it actually look in KNIME. Now I want to just show you a quick minimal machine learning workflow. So what do you need actually? You need to get some data. Here's just a table reader in this case. Then you have to partition it, as I said. Then you choose a learner to learn whatever you want to learn out of the data. And then you have a predictor that uses this result of the learner to actually predict the results for the testing data. And then you have a scorer in the end. And this scorer tells you how good the result actually is. Did the learning actually work on the specific data with this learner? And then, of course, you can use this result of the learner to create more predictors and actually put it into your own application or do further analytics. Now the question is, what kind of learner should you use? And especially in this webinar, I can only say it doesn't matter. You can choose a lot of them. A good starting point is often naive Bayes or a decision tree. They are mostly used in tutorials and introductory lessons because they're relatively easy to understand. And yeah, I would always start with them, actually, at least to have a comparison if you want to use other nodes as well. The good thing about KNIME, and this is something that KNIME shares with other similar tools and frameworks, is that the way that these learners are actually used is standardized. So you have one node that is a learner, and you can just drop in as a replacement different learners. You can use them in parallel. You can try this out. So this is a very good and intuitive way to actually see what the differences are between the results and what learner is probably the best for your scenario. We use the decision tree because I can tell you or I can show you a little bit how you can interpret the result. And this is the main strength of decision trees, is that they are actually interpretable because you actually create a model that is easily understandable. Here's a model that tells me if I should go outside, and I'm very picky when I go outside. So when the sun is shining, when the sun is not shining, I stay inside. And when the sun is shining, I first check if the temperature is actually warm. And if not, I also stay inside. And only if the sun is shining and the temperature is warm, I actually go outside. So this is why it's called a decision tree. Based on the data that you have, you create this tree, and you take your paths depending on the values that you have in your data, and then you end up with a class, with a decision in the end. And this is what is used in a decision tree classifier. And what you get for data is then a tree like this. You can explore it interactively. And this is also useful just for data mining, actually. So even if you do not really need a machine learning system, learning a decision tree on data and just look at the tree gives you a lot of insights into the dependencies between several variables in your data and so on. So this is a very useful tool in itself. When you see this tree, also in some minutes in the example, you of course have to understand how to read the tree. And this is also for your reference, maybe for later on. A quick introduction. You always have these paths. So here is some criterion that you usually have. And then you have to check your data. And here you would reach this node actually in the tree when whatever is here is smaller than 66.5. And this basically splits your data set again in all the data that is for which it's actually valid that this criterion is smaller than 66.5. And you get a kind of intermediate statistic. So at this point, this is about a wine classification. It classifies red and white wine. So at this point, we have a classification of red still, and you see, because this is the majority basically of the data, 944 data rows here, or data examples are red of 1046 overall. And then the tree decides on the next criterion, like chlorides here, and then you go on and evaluate the next one. So if you put this decision tree now in our workflow, and I show this live in a second, you have this CSV reader in this case. It reads in a CSV file that you find on the web. It is part of the example as well. It's the adult income CSV. It gets partitioned. Then we have our decision tree learner. We have the decision tree predictor. The decision tree predictor predicts all the values for the testing data. And we can have a look at the result. And we have here a dedicated node to provide an additional interactive view so we can explore the decision tree. So we switch over to KNIME. And this is just a demonstration. We will run it. And yeah, what you basically can do now, and what is I think really great in KNIME, is that you can check all the single nodes, as Magnus already showed you. So you can have a look at your original data. I have to do this very quickly now, but it's basically data about the income of people in the United States. You have some age data, some education data, some relationship data, and so on. And here is the actual interesting class, the income, and it's just the decision between lower than 50K or more than 50K. This is what this actually is about, and we want to try to learn it. So we partition the data, and here you see you can basically just adjust the split and the way you want to do the splitting. Then you have your decision tree learner. You also have some attributes. As Magnus already said, you have here the documentation, so you can learn and read about all the attributes that you can adjust. We just keep it at standard values, and then you have here your predictor. And now we can have a look at the score. And there are two ways to look at it. Very often you will see this confusion matrix, which basically tells you that of the actual data that has lower than 50K income, you have that right in 4,664 cases, and you have it wrong in 281 cases. Maybe more interesting, or in this case, depending on what you want to look at, more helpful are these accuracy statistics, where you find typical statistics that are used to understand if a machine learning approach actually works or if it doesn't work. So for example, you have here the F measure. It's a kind of combined measure, and you see it is an F measure of 0.9 for this class, which is actually quite good, 90% right. Basically a little bit oversimplified, is not bad, but you have a much worse value here for the other class. And the reason why this is much worse is, and we will see this in a second, because the data is actually skewed. You have a lot more data for low incomes than for high incomes. So, and the last thing is, we can start here. You have various views. There's, for example, this one that is already available in the decision tree learner. Simple, but nevertheless comprehensive way to actually look at the tree. But a nicer view is available via this dedicated node. So you can just connect it to a decision tree, and you get this interactive view. And this is what you have seen in the slides. And now you actually learn what it takes to get a high income. For example, you see here that we have a relationship as the first attribute that is important. I would like you to look at here. You see at the root node, at the top of the decision tree already, there is the majority decision of lower income. And already at this point, you have close to 20,000 rows that are actually lower income of only 26,000 rows. Now this can change a little bit because we did the partitioning, and this is random. So it will not be exactly the same numbers if you try it, but this is roughly how the data looks like. So this is important. And then you see, okay, if you are in a relationship and if you are actually married, you go here. And if you are not in a relationship and not married, you go here. And here you already see that 13,000 of 14,000, so a lot of them are in the lower income area. And if you want to, here still, of course, most of them are in low income. But now you can see basically the first time you get for in this higher income area is if you have an education that lasted for more than 12.5 years. So if you put more than 12.5 years in your education and are married, this means you might have good chances to be in a higher income. Yeah, a very quick introduction, but you have everything here in KNIME. And what I like, maybe there's a last word, why I think you should not use KNIME quite often, even if you know what you do and you maybe can put it together in Python as well. The workflows basically help you to actually check things, because you can look into everything into the original data, can see how the data actually looks like. You should, of course, do this anyway, but I think KNIME actually helps you doing this, because you can, with one click, check all the single nodes. So that's it from my side, and yeah, We still are with these 5 minutes overtime, but I think we have time for some questions. Thank you.
Okay, let me get my camera back on here. Okay, so we have a couple. So we had a couple tech issues for folks couldn't see the demo there at the end, but I suspect that might be a GoToWebinar issue. So I have a question about the machine learning from Mike C. Does the data input function report errors? For example, in particular, if I'm using a CSV file and I have commas in the data values, will it tell me that there's an error processing the data? And for example, if say I have a column that's called address, and one of my addresses is 265, comma, any road, comma, London, what would the user see?
Yeah, I can answer that. So I skimmed over the advanced configuration of a file reader where you can tell the reader, my data cells might contain carriage returns, or actually there is a quote character around all the cells that contain the separator inside. So if it is valid CSV, you can read it. It will actually give an error message if things don't add up, like the header is 20 fields and now I found 40 fields. So it will immediately stop and throw rather meaningful error messages either in the log, where they usually have a lot of space for text, and a smaller one in the interactive view. But it should, given proper data, so it's not like damaged data files which have like corrupted information. That is always a hard thing to get. So if it's possible to interpret the data, it will help you do that, and you can read all kinds of CSV data. And even if it's corrupted, it will immediately stop and throw an error message when things don't add up. And it's quite intelligent about it. I was very surprised. It worked quite well with lots of less optimal data we've been using in some examples.
Awesome. All right. I think there's time for at least one more question. So Sammy D is asking about the training models for the machine learning algorithms. Can you export those models after training for other applications to consume or use?
That's a very good question. You definitely can export them. So you can also use them with KNIME on a server, for example, and deploy them. But I'm just thinking if you can actually export them to use them in a different, like in Python or something like this later on. I don't think so, but I do not know for sure. But you certainly can use them in production later on.
All right, excellent.
I can also give one more input into it. I know that the way it exports is actually not some nasty internal undocumented format, but some kind of standardized format that is actually used in other environments. We can have a look at this in the blog post on machine learning with KNIME. It's a great question, and we should really follow up on that. But I guess it depends on the other frameworks you would be willing or wanting to use, what kind of models they are able to ingest. So there might be a way. I mean, if it's a standardized format, there might be a way to read it or even transform it from one format into another. We will have a look at that, and it's an interesting question.
All right. So there's a couple minutes left. I'm going to try and do a couple more questions. Sammy has followed up with what is ONNX?
You
Was
lost
that a
me
question?
Yeah, I don't know. Maybe they're asking something. Let's skip to the next one. Can KNIME concatenate existing KNIME workflows?
I would say yes, because there are sub workflows. If this is what you mean by concatenating some, so you can use your workflows and actually use them in other workflows
Yes.
as a module, basically.
So you can even turn them into a single gray box that behaves like a node in another workflow, and you can hide all kinds of nasty, like you can have this nice gray box, clean up data, which is a big mess of tons of things you do to find all the missing values and cut off some information. And you can reuse them even in different files.
Yeah, engineers love that kind of thing.
And you absolutely. And you need this because otherwise you get lost. Because as we probably a lot of people know, the great thing about such graphical environments is always that it's easy to start, but at some point you just run out of screen space. But I think KNIME does it quite good, that you can then just group stuff into a node and can forget about it and keep the high level view. So this is actually nice.
Okay, so I think we're out of time. If you have further questions, you should be able to email either of the presenters directly and follow up there. Thank you both.
I would like to add again before we stop that we intend to write a series of blog posts on the DCMI website on the KNIME things. We will post the used workflows and the data sets there as well. If people had trouble watching the KNIME interactive thing, I hope it's clean in the recording, so maybe they should have a look at the recording later. If it's a problem in the recording, please contact either Assist or Jacob or us, and we will re-record it and put it on YouTube. There's no problem there. So if people want to follow that, we will make sure that this is available.
Maybe even a last announcement. It's not even an announcement, but originally we wanted to do this in a more interactive way. Also originally at the Dublin Core Conference, which then of course took not place this year. So if you are interested in maybe joining a workshop in the future, no promises, we have no plans so far. But if you are interested in basically having a follow-up session where we do more hands-on work, just get in contact so that at least we can tell you when we do this, or that we know that there are a lot of people who would be interested in it, and we can try to find an occasion or maybe do a more interactive webinar later in the future.
Yep.
All right, well, I think we're just about out of time, and I really do want to thank Professor Pfeiffer and Eckert for doing this fabulous webinar. It's really very, very interesting. I know the attendees, they stayed all the way through the end, so you definitely got some good information out there for them. I also like to thank Jacob Jett for moderating this session. I want to remind the audience that one of your many ACES member benefits is complimentary access to all of the webinars. A recording of today's webinar and a copy of the slides are going to be posted to the ACES website within a couple of days, and they are available to today's registrants and all ACES members. Also, within 24 hours, the registered attendees will receive an email with a recording of the webinar and a survey, and I encourage you to please complete the survey within 7 days. Your feedback is really important. Again, I'm Kathy Nash with the ACES staff, and I really want to thank our presenters, our moderator, and for all of you for attending today. This concludes our webinar. Thank you.
Thank you, Kathy. Goodbye.
Thanks. Bye.
Bye-bye.